Okay, let's see. So finding the domain of these functions. So to find the domain of these functions, we need to take the denominator out and set it not equal to 0, because your domain, you first assume that your domain can be any real number. Any real number means you anywhere on the number line, you can use any number, a negative number, 0, or a positive number. You can use any numbers. That's your domain. But as we solve this, this will tell us what numbers we need to take out of the number line, and the numbers that are left will actually be the domain. So, because again, you can't have 0 end up being in the denominator. So we're trying to find out what numbers would make this little um, quadratic equal 0. So I'm going to solve this by factoring. So 2x squared, I'm going to assume that used to be 2x times x. Now, negative 15, there's lots of choices of that. That could have been 1 times 15. That could have been 3 times 5, 5 times 3, and 15 times 1. There's lots of choices there. So let's kind of set up a few choices here and see where we're going to go with that. So let's try the let's try the 3 times 5, see if that works. So 3 times 5 gives us 3x, and 2x times 5 gives us 10x. And that negative there means the signs have to be different. And can we have different signs and get a positive 7x? And the answer is yeah, we can. If I put different signs here, positive and negative there, that would make a positive 7x. So we need negative, positive. So negative, positive. All right, so that's the factor. So let's put it in. Minus 3 and the plus 5. Okay, now that we have our factors, these factors are linears, so we can solve them both for 0. So we can say 2x minus 3 equals 0, and x minus 5 equals 0. We can solve both of these. Let's see. To solve this one, let's add 3 to both sides. And we'll get 2x equals 3. Then we're going to take our 2x equals 3 and divide both sides by 2. That will give us 1x equals 3 over 2. And that's one of my answers. Now remember, this means we don't want it to equal 0. So let's put a don't equals. So this is one number that we're going to take out of the number line. Over here, we're going to add 5 to both sides. And we'll get x equals 5. And that was pretty fast. So we have two numbers to take out of the number line. So let's go back to our number line, which is right here. And 3/2 will be right about here. That's where 3/2 would be. And let's say 5 is right here. So when we take those out of the number line, that leaves this area right here, all the numbers in this area, all the numbers in this area, and all the numbers in this area. So I'm going to represent these 3 areas. Let's write down the 3 areas here. Here's the number line here. And here's where the 3/2 would go, and here's where the 5 would go. And we're not going to use those numbers, so I'll put little zeros. So I need to represent this area for the domain, this one, and this one. So this area right here for the domain, we'll say that that area is from negative infinity to 3 over 2, and that's before you get to 3 over 2. And we need this area right here in the middle. I'm going to call that all the numbers between 3 over 2 and 5. And then I need that area right there. That's going to be all the numbers, should be a union, from 5 to positive infinity. And this is my domain. Okay. I wish I could put the D in front of that, but that's my domain. So once again, let's find the domain for this function here. So again, we're going to assume all real numbers. Okay. That means any number before 0, like a negative number, 0 itself, and all the positive numbers. Now let's find out what numbers we don't need. So x squared plus 2x minus 15. I kind of forgot my not equals there. Okay, and not equals 0. All right, let's solve this by factoring. And the x squared, I said that used to be at x times x. Now the 15, there are lots of choices for 15. 15 is 1 times 15. You have 3 times 5, 5 times 3. and 15 times 1. Lots of choices. I'm going to choose the 3 times 5. I think that'll work. 3 times 5. And that'll give us 3x here, and that'll give us 5x there. And we want the signs to be different and get a 2x. Well, different signs and getting a positive 2x, I think it'll be positive negative here, because that would make a positive 2x. Okay, different signs. So that means we need a negative and then positive. So negative and then positive, and it's factored. Now let's take each factor and set them equal to 0. So x minus 3, set that equal to 0. The x plus 5, set that equal to 0. And then we're going to solve both linears here. Oh, let me raise this up a lot. Wow. Okay, I'm running out of room here. Let's try that. Okay, that's better. Okay, so let's solve this one. So plus 3 on both sides. And we get x equals 3, or can equal 3. And here, minus 5 minus 5, x cannot equal negative 5. So those are the two numbers we're going to take out of the number line. So here's the number line again. And this is where negative 5 is, and this is where 3 is. And we're taking both of these numbers out. That leaves us 3 areas. Okay. This area here, the second area there, and the third area there. Since it's hard to see down here, I'll write my domain on this card here. So domain, this area right here is everything from negative infinity to negative 5. This area right here is everything from negative 5, all the numbers from negative 5 to 3. And finally, that third area right here are all the numbers from 3 to positive infinity. And that's your domain for this function f.